Zfighting is a fairly common problem in 3D rendering and live walkthroughs. It gets its name from the Z buffer of a video card, where the 3D scene's depth information is stored as a texture. Z in this case represents the axis pointing into the screen. Zfighting can happen for a few different reasons. First of all, simply having overlapping faces that share the exact same space can cause Zfighting. As we can see here in 3ds Max, we've got a bookshelf up against the wall here. Now the bookshelf has its own back face there that you can see, and that is sharing the space with the wall's polygons and causing some Zfighting. Another reason is a lack of precision in the Z buffer. Certain situations can increase the chances of Zfighting occurring too, including very large objects and translucent materials and a few other possibilities. The telltale sign of Zfighting is what you just saw here, which is basically flickering geometry. If you see this, you've probably got a Zfighting infestation. What's happening is one set of the faces is trying to be rendered in front of another, and they fight back and forth for dominance. This can be very jarring to your viewers, reminding them that they're looking at computer-generated imagery. Fortunately, most modern video cards boast up to 32 bits of depth buffer, and this can greatly help mitigate the appearance of Zfighting. In fact, if you're running a very powerful modern card, you may not see any Zfighting, even if things are overlapping in this way. But if your viewer is running the scene on a lower-end PC, they might not have as powerful of a video card, and the Zfighting may be more of a problem. So it's important for you to test out your scene on lower-end graphics cards if possible to find out if you've got any Zfighting issues. Now fear not, fixing Zfighting is generally very easy to do. Let's look at some of those problems and how they can be fixed. So first of all, with our Zfighting here in Max, the easy solution here is, well, you can do one of two things. First of all, we could pull this away from the wall so it doesn't have any polygons that overlap with the wall. Even the smallest space would solve the problem here. But if you can't move your object, if it needs to be where it is, the other option, of course, would be to delete some of these faces. Now I know I can delete these faces here on the wall because they're completely occluded by other parts of the wall. There's trim, there's crown molding up here, the fireplace blocks this area. You won't see any of these faces here, so they're pretty redundant anyway. By deleting these faces, I can avoid any Zfighting there. Again, the other option would be to move it away from the wall. Now this may be the only option you have. You may not be able to delete faces. You may just need to separate your objects a little bit, especially if those objects are going to be really far away. Generally, Zfighting, when you're in a scene that's really small and everything is up close, you're not going to see it as much. But in a larger scene, say an exterior scene, you're going to possibly run into Zfighting issues, especially if things are very far away. And this is where the lack of precision comes in. And we'll look at a way to fix that. Now, another option would be to use LODs. And again, this is mostly for scenes that are very large and exterior scenes. If you've been following along and you watched the LOD video, you'll know how to create LODs for Unreal. And then generally what you'd want to do is any objects that are causing Zfighting issues at a greater distance, well, you'd want to have a lower LOD for that object that removes whatever parts are offending, whichever parts are causing the Zfighting. Chances are you're not going to be able to see those parts from very far away anyway. All right, so here in Unreal, we've got an issue here that's kind of a unique circumstance for Zfighting. And it doesn't exactly count as the flickering Zfighting, but it does still qualify as a depth problem. And that is using translucent materials. So what we've got here is I've got 3 translucent materials on top of each other. I've got a translucent wall, which isn't normal, but for demonstration purposes, I've made the wall translucent. I also have a translucent curtain and then a translucent lampshade here. And we can see clearly that there's a depth issue here. And that's because of the way translucency is being sorted on the video card. So in this case, the best solution we've got is to remove some of the translucency. And that will help fight some of these depth problems. But we can also go into the settings and change how translucency works. So if we go ahead and open up the settings, go to our project settings, and we'll do a quick search here for translucency. All right, and we can see under translucent sort policy, it's currently set to sort by projected Z. So if we change this to, say, distance, we get a different look here. So this is a little better, but still not perfect. We've still got some bouncing Z's here, some bouncing Zfighting. We'll try sort along axis, and that's not any better. So you can see here that especially with translucent or transparent materials, Zfighting can become quite a bit of a problem. So let's open up our wall material here, and we'll change this back to an opaque material. And that should help us out quite a bit, actually. All right, so just by changing the wall material, that's helped out quite a bit because now we only have two translucent objects that are competing. Now another option we can try here is the lampshade material. We'll open that up. Right now it's set to two-sided, so let's make it not two-sided. And that helps quite a bit. Now that's because the lamp is composed of a solid mesh that has two sides. It's not just a billboard, so that billboard with the translucent material was what was causing the depth issues. Now there are a few settings that we can tweak in order to try to get a better result, and the first one is the NIR Clip Plane. Now the NIR Clip Plane is basically, if you know much about cameras in 3D, you know that they have what's called a view frustum, and that has a far plane and a near plane where things are clipped out, they aren't rendered. And the NIR Clip Plane is obviously in the front part of the camera, the very closest part to the camera lens. You can adjust that NIR Clip Plane, and by making it a longer distance further away from the camera lens, it can actually improve the Zfighting issues in scenes that are really large, exterior scenes and whatnot. Now the only problem is you don't have access to the far clip plane in Unreal, which means that adjusting the NIR Clip Plane may not have much of an effect because generally you want to adjust these two together. They work in tandem. But I'll show you where you can actually tweak it. If we go under Settings, and then Project Settings, we can do a search for NIR Clip Plane. And mine is set at 10, which I think is the default value. We could obviously make this higher. Generally, you want to have a result of between 10 and 30, but if you wanted to make it up to 100, you could certainly do that. Just bear in mind, by tweaking this, you're also going to be making it so that things that are very close to you will be clipped out, and that may create an undesirable effect. So it really depends on the scene you're working on. If it's an interior scene like this, you generally want to keep your NIR Clip Plane very low. And if it's an exterior scene where they can't get close to things, you can increase that NIR Clip Plane. Now, the thing is, if you change the setting in here, you're going to have to shut down Unreal and restart it. But you can change it inside of the console or the output log. So if we go into the output log and we type in r.set NIR Clip Plane there. So for instance, I'm going to go ahead and set it to 100. And we can see here how it's clipping out very close to me. And that looks, obviously that's undesirable. We don't want that. But if we were really far away, we wouldn't notice it. And that could help improve our Zfighting problems. Now, we can also do this in a blueprint. So when we run our level, the blueprint can play these events for us. So let's go ahead and do that now. We'll go into our blueprint for the level. And from event begin play, we'll just drag off here and we'll do a search for execute console command. All right, and in the execute console command, we can obviously type r.set NIR Clip Plane, and we'll set it to 100. Now, another thing we can do to help improve the accuracy of our Z buffer is to add another command, another console command that basically sets the depth buffer's format. So the options we have for setting the format are 0, which is basically off or poor quality, and then 1, which is the default value, and that is kind of a low quality. And then finally we can set it to 5, which is a high precision value. So let's do that now. We'll go ahead and drag off of our first console command, do another search again for execute console command, and this time the command we want to use is r.gbufferFormat, and we'll set it to 5. Now keep in mind you are increasing the depth buffer's accuracy here, and that can help combat Zfighting. But it does come at a performance cost, so use this console command with caution. Zfighting is a problem you'll most likely encounter when creating large exterior scenes, especially with things with like tall buildings that are very large, take up a lot of space on the camera, or when you're using a lot of translucent materials. But even small scenes with overlapping geometry can sometimes have issues. But knowing how to spot Zfighting and knowing the techniques to fixing it will have your scenes rendering error-free. Up next, we'll look at how to solve some common light map errors.